Here's problem 1429. A dictator has built a bunker for his use in emergencies. Its dimensions are shown below. When it floods during a tropical storm, the gauge pressure at point A in pascals is, normally if we're talking about a gauge pressure, we're talking about the difference of pressure at some point with relation to another point, usually atmospheric pressure outside. So we're going to compare point A to point B, which is at the entrance to this bunker. And point B is open to the atmosphere. Point B is under atmospheric pressure, which is bearing down at that point. Alright, so we've got this enclosed fluid. So Bernoulli's principle applies to every point within that fluid. And in essence, what we're interested in is how far below point A is in relation to point B. Now we've got these dimensions, 15 meters, and then 15 meters here, and then another 5 meters here. So this distance right here is 10 meters. And if I add that 10 meters over here on the side, then the total distance all the way down to A is 60 meters. So if we define point A as being our 0 point, then the height of B will be 60 meters above that. Sounds good. So we have that within an enclosed fluid, Bernoulli's principle says that the pressure at A plus 1/2 rho velocity at A squared plus rho g height at A equals the pressure at B plus 1/2 rho velocity at B squared plus rho g height at B. In this case, our height at A is defined to be 0, and this water is not actually moving in either case, so the velocity at A is 0 and the velocity at B is 0. The pressure at B is atmospheric pressure, and our gauge pressure is the difference, as we're looking at this, the pressure at A minus the pressure at B, which is the pressure at A minus atmospheric pressure, and that is equal to what's left over here, which is rho g height of B, which is going to be 1,000 times 9.8 times the height, which is 60 meters, and that is equal to 5.88 times 10 to the 5 pascals. So that is our gauge pressure, the difference of our pressure with respect to atmospheric pressure, 5.88 times 10 to the 5 pascals.